Hello everyone. In this video, I'm going to talk about execution stage of y86 sequential processor. Let's get started. Here we have a figure or block diagram we need to implement. And it is from Bryant book, so you can go ahead and read some detailed explanation. And most of the information I'm going to give you is written in that textbook. Okay, so if you don't, if you need super detail, you can go ahead and read. Okay, here let's take a look at one by one. So first is the main component of this stage, which is ALU. So it performs the operations like add, sub, AND, or XOR. So it takes two data inputs, ALU A, ALU B, and it takes one control signal, which is ALU fun. And then it outputs one data, which is val E, value from execution unit, and one condition code, actually 3-bit condition code this way, this direction, okay? So you can refer to Vahid book chapter 4 to implement inside components, right? Adder, subtractor, and or XOR units. Okay, good. Yeah. So then, how does ALU select these among these instructions? It is controlled by this signal. Okay. So it is actually the value iPhone in the machine code. Okay, so you can go back to the instruction format and then see the list of the I function. So let me go to the next slide quickly. So for example, so for OPL instruction, which represents arithmetic operations, has function number. Okay, so you can go to the Bryant book and which one is exactly what. Okay, I remember only one. So function 0 is add operation. Okay, and also we have y86 instruction, which represents the jump instructions, and it has also function ID. And I don't remember which one is what, but you can go ahead and then refer to the Bryant book or some other tutorial slide. Okay, anyway, then we understood what ALU does. Okay, and then next, which is ALUA component. Okay, and what it does, it does similar to the like source A, source B, test EM in the register file, like decoding stage. Okay, we discussed about this, and it actually selects either RA or RB. Okay, so let's go back. So here, ALUA and ALUB does same thing. Okay, so for ALUA, it selects either value A or value B, depending on the instruction. So that's why it takes I code as well. Okay. So for example, IR move instruction, which has constant value, immediate value, and we move immediate value to register RB. Okay. In this case, we need to select value C, not value A, right? This is a one typical example. And then we have to know all the instructions. All the instructions. Yes. And then next, for in ALU B unit, it takes only one data input, value B. Then why we why we have this module? Actually, the thing is, this unit select value B or 0. What? Why 0? Okay. So again, let me give you one example, typical example using our IR move instruction again. V and RV. Okay. So we want to move data V, constant value V, to the register ID RB. Okay. In that case, for this instruction, actually this data should go to the register file side. But how go to there? It goes to register file through execution unit. Okay, so then we don't want to compute anything. We just want to forward this value to the register file. Okay, so in that case, how do we do that? So let's say we take value C and then put it to the first data input, and then second, we just, so for IR move instruction, instead of taking select value B, we put just 0 value. And then which operation we do? Add operation, 0. Then we just do V plus 0 and then output. Then it will go to the, this line will go to the, is connected with register file, and then we can just store this value as it is in the register file. Okay, that's why ALU B block is here. Okay, good. Next, which is ALU function. So ALU function actually, what's that? Puts I function basically. Okay, so like if what type of instructions do have I function, OPL instruction, and JXX instruction, right? But then what again? Why not just directly put ifun here? Because of some other instructions which will just bypass this instruction, like IR move instruction again. Okay, so IR move instruction, for example, okay, does not have function instruction function code, then which value would be here? Actually, 0 at this position, 0, right? So let me write pseudocode for ALU function here. So if I code goes to what, OPL, or I code is JXX, then this module outputs what? I function itself. Okay. Otherwise, I'd like what is output name? ALU fun. Otherwise, For other instructions, we need to put ALU fun 0, right? Okay. So if you guarantee that this ifun value for other instructions, not OPM, not JPP, then if you guarantee I function is always 0 for other instructions like not OPL, not JXX, then we don't need this part actually. Okay, so think about it. So depending on your design, yeah. So for other instruction, it is always this line is always 0. Then actually you don't need. Just directly connect ifun to this ALU fun. Okay. Okay. Then we discussed ALU fun, what it is, how to implement. And then next is setcc. This one. Okay. Setcc is also simple. So it output control signal, like whether to store condition code or not. Okay, it's simple. Like if I code, so when do we set condition code? When we execute in OPL instructions, right? So then if I code is OPL, then it outputs 1. Otherwise, it's 0. Okay. Then in the CCL block, depending on this signal, it will either store the value coming the control condition code or not. That's it. Okay. So these two modules should be super simple. Okay. Then we are done. But we didn't. Yeah, we talk about this and this, like what they do, but we didn't go over all the instructions and then um, get an idea which value we need to select. Okay, so actually I already summarized that in this table. Okay, so you can refer to this table. So let me read this table. Okay, so for instruction like R move, we select val A, and then we select 0 for ALUB. And also for IR move instruction, we select val C, and we select 0. Okay. So you can refer to this, and then let me explain a little bit more detail why we select value A or value C, something like that. Okay. So again, so first, oh, by the way, so here X means maybe we don't care, or we don't have to think about it, or maybe something you should consider. But you try and then take a look. It depends on your design, so I didn't mention exactly what value we should take, or just leave as it is, or yeah, you think about it. And it's not very difficult, so I'll leave this as a unknown for you. Anyway, but these 1, 2, 3, 4, 5, 6 instructions are important. Oh, sorry. Sorry. 1, 2, 3, 4, 5. 5 instructions we have to select. Okay. Anyway, so for RR move L instruction, so for ALUA, do we have to take which value we have to take? Value A or value C? It's simple. We don't have value C here in this instruction. Definitely we need to select value A. by the way, value A actually coming from register, right? So this is the value. The value A is the value of register A, and then ALU B, value B or 0. Which value? Definitely, we need to read value. Oh, sorry. Do we need to read value B? No. Why? We want to put data of RA to register RB. Okay. Then we just want to forward this val A. Then we put 0 and then add. Use add, right? So we use val A. We just select the val B for ALU B. Okay. Next, let's go a little faster. So for IR move instruction, definitely we need which move immediate value to register RB. So we need to select val C, and then we select val C for ALU A, and then we select 0 for ALU B, right? And then next, IR move instruction. Okay, so it actually move data of RA to memory RB, value of RB plus D. Okay, so in this case, which one? Which one we should select for ALU A? ALU A, like value A or value C? Here, do we have a value C? By the way, yes. What is value C here? Displacement is the value C. And here we, for our M move instruction, we need to calculate memory address, which is value of RB, which is val B plus D. This is the memory address, and we need to add these two values using ALU, right? Then we need to read val C. So we should select val C here. And then we need to select val B for ALU B. Okay. Then what about RA? RA will be RA was used to read the value A, right? And then that value A directly go to the memory module, which right? So it is nothing to do like register A or value of register A is nothing to do with ALU. Okay, good. And then next, MR move instruction. So which move data in the memory to the register A. Okay. So for ALU A, which one we should take? ALU A or ALU B? So it is same with RM move instruction. So we need to calculate memory address, which is val B plus D, and D is actually val C. So then we should select val C for ALU A, and also we select val B for ALU B. Okay, and what about RA again? So this is now it is the destination register, like to store data coming from memory. Okay, again it is nothing to do with ALU module. Okay, good. Next, OPL instruction. Okay, so it computes, it does arithmetic or logical operation using these two register values. Okay, then definitely it's simple. We need to read val A for ALU A, and we select val B for ALU B. Okay, done. It is simple. Okay, then what about JXX instructions? Okay, So it is, we want, so this instruction actually jumps to the target destination, which is the address of a certain instruction depending on condition code, right? So this jump instruction actually does not do anything with ALU, okay? So I didn't define ALU-A and ALU-B, okay? Let me give you give me something more for X case. So in my design, whatever value is going to ALU-A and ALU-B, it works, okay? But if in your design, maybe not. So you should specify something, but in my design, uh, any data, if even though any data goes to ALU-A, ALU-B, it's fine, okay? So that's why I used X here, okay? So you will figure out if you exactly follow my tutorial, then you just don't have to care about the instructions with X. Okay, I think we are done. Okay, and then in the next video, I'm going to demonstrate execution unit using a logic sim. Okay, bye.